So today's thing is really going to get us into more detail about how we know Earth changes over time. Evidence is a huge deal in science. We have no science without evidence. So this tutorial, as you saw in the other video, really delves into several pieces of important evidence about how we know Earth has changed over time. The first one we really will look at is weathering, erosion, and deposition. Now, I know that the program goes into it, but for a little bit more detail, remember, this is something we covered in 6th grade. I know it says 8th grade. I reviewed it in 8th grade too, but remember, from 6th grade, weathering is when we break down rocks. So we could see this for things like how glaciers break down rocks. Then we have erosion. That's when we carry sediment from the broken down rock somewhere else. And depositioning, the idea of repositioning the rocks. You kind of see it in here. The sediment comes down, either down the hill or comes down and like from an explosion, anything big happening. A glacier could have gone by and made rocks come out. Makes these beautiful layers here. And the layers pile on top of each other. We talked about this with the rock cycle, how sediment rock is made by lots of rocks on top of each other. And the bottom layer gets stuck. Meanwhile, dead animals fall in and layers go on top of them. So that weathering and erosion is going to give us a lot of evidence that the Earth has changed because we can physically see how things like rivers have eroded into the stone to show how rock has changed. The next one it talks about are layers of rocks. So as we were just saying, those layers of rocks are going to cause a lot of things that we can look at. We can physically see how the layers of rocks have different creatures in them, and they have different materials. So you can see here how there's different colored rocks and different animals and organisms in them, and that tells us that things have changed. Otherwise, we'd have all the same levels with all the same organisms all mixed together. The next one you're going to talk about is the fossil record. So in here, you can see how fossils have changed over time. Each layer has very similar looking creatures in them. Because as life changes, it's going to die at different rates and things are going to get covered up by more sediment as more rock layers form over them. Then we're going to go into tectonic plate movements. You spent all last unit talking about tectonic plate movements, so this shouldn't be too big of a surprise that the plates look different than they used to. So we've got 225 million years ago, we had Pangaea. Then we broke into Laurasia and Gondwana. Those of you guys who came by for our Wednesday group chat, we talked about those a little bit. Then we see them separating even more and even more here. And that goes into with the cause of our convection currents. This movement, just like we talked about all in the last unit, has tons of evidence. Once again, we can see the change happening here. We can see here that the plates fit together. The continental shelf, that's the teal areas, and the orange areas show areas that have similar rocks and similar rock formations. So we know that they used to hook together. We also see a lot of similarities in fossil records. It's like you can see here across South America and Africa, the same type of Triassic reptile all the way across the two of them. It wouldn't make sense for South America to hook anywhere else because it wouldn't have the same fossil patterns. We see all sorts of really good ones like Glossiopteryx and all these guys going right across the continent, proving that they were there. So we have tons of evidence that really shows us that Earth is changing over the time. It's not just one stagnant rock, and that all goes back to those convection currents that we talked about last unit.